Now, why all this talk about CO2 levels? Well, first off, again, we're discussing the Anthropocene, or the fact that humans have had major impacts on the planet that will be seen for many, many generations, if not millions of years, or even for the rest of the time that Earth is around. These changes in the atmospheric carbon dioxide levels, or atmospheric chemistry, as well as changes to the ocean's chemistry and CO2 levels, will be seen for millions of years to come. Not only that, though, but these CO2 levels have an interesting effect on our planet. One, carbon dioxide has an impact on planetary temperature. It is what we consider a greenhouse gas. On every planet that has carbon dioxide, scientists have noted that CO2 acts as a blanket in that it traps radiant heat being lost from the planet into space and keeps it from draining into space so quickly. It's kind of like a blanket, keeping the Earth warm. There are other greenhouse gases as well, including water vapor, methane or CH4, and others. However, CO2 or carbon dioxide has the biggest impact on the Earth's temperature. And this is seen in a very famous graph generated in multiple peer-reviewed scientific journals where carbon dioxide levels were measured from ice cores along with known measured temperatures from around those same time periods. As you can see from this graph, the blue is CO2 levels and temperature is in red. They track very, very closely. Temperature does not track with methane levels or water vapor levels nearly as well, indicating carbon dioxide has a major impact on our planet's temperatures. Of course, CO2 can result from lots of activities, from depletion of forests, from volcanic activity. But what we have seen, as I mentioned recently, is a dramatic increase in these CO2 levels as a result of human activity from the industrial era. Since the Industrial Revolution, the use of fossil fuels or burning of CO2 stores has released carbon dioxide into the atmosphere, causing a dramatic shift in CO2 levels over a very short period of time. As you can see from this graph, it usually takes thousands or tens of thousands of years to make the same change that we've made in 100 or 150. 10 times or 100 times faster. This change in temperature is seen not just on land, but also in the oceans. The increase in temperature in the oceans has contributed to melting of the ice, especially at the poles, and has resulted in the Arctic Ocean losing ice cover to around 50% of what it was just 30 years ago. You can see that in this image here. Not only is the Arctic losing ice at a record rate, but other ice covering land, such as Greenland, is also melting exceedingly fast. And this has led to rising sea levels all over the globe. Different areas of our planet see a different increase in sea levels, but it's fairly consistent that everywhere, as a whole, we've seen an increase in sea levels. This has led to an increase in flooding, especially during hurricanes and tsunamis, leading to many casualties and death and destruction of structures. The increase in oceanic temperatures doesn't just melt ice and rise sea levels, but also contributes to the strength of hurricanes. Hurricane wind strength is derived directly from the temperature of the oceans. The warmer the oceans, the stronger the hurricane. This is why hurricanes are more common in summer. As we see ocean temperatures increase, we see the strength of hurricanes increase. It's directly related. Not only does an increase in CO2 levels affect ocean and planetary temperatures, the CO2 in our atmosphere is absorbed by our oceans, and in the oceans actually turns the water acidic. It is a simple chemical reaction that occurs whenever carbon dioxide mixes with water. CO2 in water turns into carbonic acid, making the water more acidic. The same exact thing happens in your blood if you were to hold your breath and accumulate CO2 in your blood. This ocean acidification over the last 100 years has resulted, on average, for the oceans being 3 times more acidic than they were 100 years ago. When viewed on the pH scale, the numbers are actually quite small. But the reason for this is that the pH scale, much like the Richter scale used for earthquakes, is logarithmic, which means a single number, like a difference between 4 and 5, is actually 10 times worse. Moving past the carbon dioxide levels in the atmosphere, though, humans have made dramatic and long-lasting shifts to our planet in other ways as well. For instance, one of the things that humans have been doing for thousands of years is altering the landscape. Although in the last 100 years, this has gotten much worse. Specifically, mining, digging for metal or other minerals, building roads and dams, altering the landscape for agriculture, and redirecting rivers all permanently alter the landscape. Humans have been doing this for thousands of years. You can see evidence of agricultural tiered systems in rice growing in Asia and corn growing in Central and South America for thousands of years. And these impacts on the land will last for many, many thousands of years more. But one of the biggest impacts is mining. Currently, today, mining alone moves more earth every year than all the rivers on Earth combined. And these changes to our planet's crust will be visible in the geologic record for millennia. Not just that, but trace elements are also visible in glaciers and the soil on Earth. For instance, if we take a look at some of the glaciers on Earth, there's evidence of mercury and chlorine in these glaciers as a result of atomic weapons testing and coal-fired power plants. Chlorine in particular, from the 1960s atomic weapons testing, can be seen in the Upper Fremont Glacier. In addition, mercury is released with the burning of coal. This mercury accumulates in the atmosphere, and much like the chlorine from atomic weapons testing, rains back down on Earth, coating the Earth's soil and glaciers with this mineral. Coal-fired power plants in the 1970s and 1980s contributed significantly to the mercury found in the soil and on glaciers. And the evidence of this is still there today. In addition, those atomic weapons testing from early in the 1900s, also released radioactive elements into the atmosphere. The fallout from these nuclear weapons, including plutonium, will be evident in the Earth's strata for hundreds of thousands of years. Nuclear power plants, such as Chernobyl and the Fukushima Daiichi nuclear power plant, releasing radiation into the soil and the oceans, will also remain evident on our Earth for thousands and thousands of years. Lead also has accumulated in our atmosphere as a result from the use and burning of leaded petroleum. This is why when you go to gas stations now, they commonly reference unleaded gas. And that's because, as a result of actions taken by the EPA and the US government in the 1970s, lead was removed from petroleum in the United States, eliminating this pollutant from our air and our atmosphere locally. Humans have also contributed significantly in other ways as well. The formation of megacities has led to significantly and permanently altering the landscape. Taking a look at how San Francisco used to look before all the landfill versus how it looks now, that peninsula is much bigger currently than it was in the past. And this is very common with lots of megacities around the globe. The formation of these megacities also requires the pouring of massive amounts of concrete. And all of this concrete also contributes to CO2 levels in our atmosphere. Nanoparticles are also found in our atmosphere, water, and soil. These nanoparticles are found in lots of household goods, including cosmetics, household cleaners, paints, and other items. While likely harmless to human health, they do enter the food chain and could potentially make large changes over the long term.